All right, let's go. One to, damn it, can't, 1 to 690, all right? How many questions they have? 600. Hopefully they didn't add any questions to it. 698. So last time I checked, it was still 690, and it's been only a couple of days. They already had 8 questions more. All right, never mind. 698. Okay. Today is Sunday, so 7 divided by 5 is 1. All right, so just one time. 219. Hopefully it's not a hard question. All right, contain duplicates. I mean, contains duplicate. I put the wrong S to the wrong word. All right, so, okay. 3, 2, 1, go. Contains duplicate 2. Given an array of integers and a integer k, find out whether there are two distinct indices. Who the text me? Okay. Let me check my text. Damn it. Given a array of integers and a integer k. Okay. Find out whether there are two distinct indices and I and j in an array that such that some number I is equal to numbers j, and the absolute difference between I and j is at most k. Okay. Find out whether there are two distinct. Okay. So okay. Okay. No. So basically they want to find. Excuse me. They want to find two identical elements in the array at different positions, and the difference between the positions should be less than or equal to k. Okay. Sure. Whether they are a boolean. Okay. Sure. No problem. Okay. So we have this array and this position difference. So what do you do? Let me check in time. How are we doing with time? Okay, 2 minutes. Took us 2 minutes to finish reading the questions. Okay, so now to check. So first of all, we had the solution is to brute force, is to iterate the array one by one, right? We start from the first element, and then we're going to check each, or we will go for one element from 0, from its index to k. We're going to check if there is any element that is equal to this element. Okay, you know what I'm saying? Okay, now hopefully I explain it clearly. Now, so for every element, we're going to do 2k. This is the brute force way. Or we can only just do 1k because it's not necessary to do like 2 ways, because I was thinking k to this way plus k and minus k, but as a matter of fact we only need to check the positive position. Okay, so we're going to start from the first element and we're going to iterate through k elements, Kate element and John element. Anyways, but the problem with that is and we're going to check if they're equal within k, the range of k. So the problem with that is for every element, we have to check k times, right? We have to check k times. So it's n times k, right? So is there any way that we can do it in n times, right? In big log of n? I think the weakest case, I think the best case is n, because we at least have to iterate through all the elements in the array, right? Okay, so now we're going to create a hash set, all right? So whenever we see we're going to create a hash set, and so we're going to create a hash set, right? Okay, we're going to create a hash set, and we're going to iterate through the array, and for every element we're going to put this element. First of all, we're going to check if the element exists in the hash set. If it does, which means this is a duplicate, right? So we're going to get the well, actually, as a matter of fact, we should get a hash map, because we want to because we want to keep track of the index of the previous identical elements, right? Okay, so now, so we see a element. We're going to check if the hash map contains this element. If it does, we're going to check this index, and if the difference right. So if the difference is larger than, the reason why I paused, because I was thinking, can we use hash set, right? Can we use hash set? Well, the problem is no, because hash set doesn't keep track of indices. So we have no idea what index this previous element has. Okay, now how are we doing with time? 8 minutes. All right, cool. Now, okay, so hash map, and we're going to keep track of the okay, so to keep track of the value. So the key is the value of the element, all right, and the value is the index, okay, the index, right? Okay. So if it contains this element, if it does contains this element, then we will, if it does contains the element, then we're going to check if the difference is less than k. If not, we're going to update this. We're going to update the information of this key, right? Okay. If it doesn't contain, we'll just create a new node in the hash map. Now, okay, right. So I think that's pretty clear. So let's see, map. So first of all, we need to keep track of the number and also the indexes. Now we'll call it hash map is equal to new hash map, right? Now, integer and integer, right? Okay, right. Now this is the base of our little function, and so we're going to iterate through the so first of all, we're going to iterate through this array. No, why not? Because we need to keep track of the indices, so we can't do for each. So we should start with I, so that we can keep track of the indexes as well. Now, I++, and okay, so if hash map, you know what, I'm just gonna call it table because it's hard, it takes longer to type hash map. So if table contains key, right? If it contains numbers I, right? So if it contains this key, which means we got a duplicate, right? Okay, so what we need to do is we're gonna get the index of this. We're gonna get the index of this key. We're gonna get the index of this element, and then we're gonna check if the difference minus, well, actually, math. Well, actually, I is gonna be larger than, so I minus index is larger, or so the difference can be less than k. So it can be it should be, because I is larger than index anyways, so the difference should be less than k, right? Right? It should be less than k. So less than or equal to k, right? Okay, so if less than is, if this index is less than or equal to k, which means that's what we want. So we return true, right? That's what we need, right? We just need to return if it contains the two elements that satisfy the requirement, right? Okay, now that's good. So, but if it doesn't satisfy the requirement, what do? So we're gonna update this hash map node. All right. So we're gonna put the value of this. We're gonna put the value of this element as a key, and then update the index. So which means it's this one, right? Okay. So now that's resolved. Okay. So if else, we're gonna put update the index, right? Okay. So what if it doesn't contain, right? If it doesn't contain, we will just put this numbers. If it doesn't contain the element, we will just add this node to hash map, right? So it's hash map, put this, and did you find anything? Do you find that this step and this step are identical? So we don't need to do this actually. So see if we can simplify the code. We are good with this, but I'm just trying to see how we do in time. 2 minutes, all right? So for the sake of time, I'm just gonna exit out of this and return false, because we haven't found any identical numbers or duplicates that satisfy the requirement. Okay, so if it contains key, then we can return true. Well, we don't even need this anyways. Okay, so if it contains key, what the heck? I just press Command S. There. All right. How are we doing with time? Okay, if contains key, then we're gonna put blah blah blah. So if it contains key, we're gonna check if it fulfill the requirement. If yes, then we will update it, right? If yes, we'll just return true. If not, we will just update it, right? But if it doesn't contain key, then we will still put the, okay, I think we're good. Alrighty, so I think we're gonna have an empty. We're gonna have an empty array and see how that goes. 3, 4, 6, 2, 3, and then we're gonna have 5. All right. How about 19? No, 5, just 5, just 5. Did I just? I just put map. Jesus fucking Christ. All right, I'll just change it to map. Don't tick. The timer. Don't tick. Fuck. All right. Okay. I'll just submit it then. Great. Okay. Cool. So our logic was right, and we also simplified the code by putting map.put at the end. So great. All right. Thanks for watching.